Hi, this is Jay from Bloch, and today I will try to highlight some of the aspects of the finance industry that will be affected by the quantum computing revolution that we are having. And after that, I will also help you to build upon this information that we will gain from this video, and I will tell you how you can utilize this channel for the same. All right, so let's get started. Before we dive into the finance industry, let us take a moment to understand why we need quantum anyway. It turns out that the Moore's law can be a very good starting point for this discussion. In simple words, Moore's law states that the number of transistors on a microchip doubles about every 2 years, though the cost of computers is halved. Let's try to understand this in a bit more detail. The Moore's law was stated in the year 1965, and from then until now, we have actually seen a decrease in the size of transistors, and while computational power kept on increasing. All right, but so far, the computers that were created were in the classical domain. So the governing theory was the classical physics. But now it turns out that the size of the transistors have decreased to such an extent that the quantum mechanical effects have come into the picture. So now we have to deal with the quantum domain, all right? And therefore, it has become inevitable to just stop investigating this quantum thing, all right? So we have to try to investigate the quantum computing to increase our computational capabilities even further. And if you are still not convinced why we need to investigate quantum computing, then let me give you two more reasons for it. So the very first is the less runtime, and the second is less memory. So it is believed that a quantum computer can perform computational tasks when much less runtime and with much of less memory as well. And any such computer would be highly desirable to solve any computational problem. All right. So now, since I have already told you the reason why we need to investigate quantum computing, let us try to understand the challenges that the financial institutions are having with respect to this quantum. All right. So the very first is the data security. The second is big data, and the third is the regulations. So let's try to understand each of these in detail. So the very important concern with respect to quantum computing is the data security, and particularly which is the public key cryptographic standards. So this is nothing but encryption model, and which is used by financial institution to exchange very important sensitive information, and it is also used in electronic commerce. All right, it is the core technology for it as well. And a very common algorithm for the same is the RS algorithm, which is based on some computation. And this computation cannot be done by any classical computer, all right? But it turns out that our quantum computer can do this computation. So if quantum computer can do it, it would just mean that this encryption can be broken by anyone, all right? Fortunately enough, for as of now, we don't have quantum computers that are powerful enough to break the encryption. But if we are able to progress towards the quantum computer that is able to do this, then it's a very concerned situation for the financial institutions. And this situation has led to something called quantum cryptography. So, the quantum cryptography is a field that tries to ensure that the advancements in quantum computing do not affect this sector in a bad way, and also use quantum computing to make these cryptographic standards high and make new algorithms for this cryptography. All right. Let's move on to the second topic, which is the big data. All right. And since sometimes the data that we are gathering, the companies are gathering, has seen a huge increase in the volume, and this data that is stored by the companies is used to make develop decisions that are utilized in the business that eventually lead us them into the more revenue. All right, and this again has led to the emergence of fields like machine learning. All right, but again, as I just told you, that the volume of data is too high, and it becomes more difficult for the classical computers to do it. Of course, we have computers that actually perform this computation, but again, it's computationally expensive. So again, it becomes important if we can utilize our quantum computer to perform these computations much more faster than the classical computers that we have right now. The third is the regulations. So there are many regulations that are put forth, and uh, it needs the financial institutions to be bound by some of the metrics. All right, so they have to be correct with respect to some of the metrics, but calculating these metrics can be computationally expensive, and again, it actually has some of the computation that is stochastic, and therefore our quantum computer again comes into the picture, and again it makes it desirable to use quantum computing for these calculations as well. So let us try to understand the role of quantum in finance. So the very first field that quantum will affect is of course machine learning. You must have definitely heard something called quantum machine learning. All right. And apart from that, we also have numerical risk modeling and the optimization domain as well. So let us try to understand each of these in a bit more detail. So the very first is machine learning, and talking about a very common problem solved using machine learning is fraud detection. So this is nothing but trying to predict a fraud credit card transaction, for example, and it is done using some learning algorithms. And again, we have some quantum versions of these algorithms that are trying to outperform these classical machine learning algorithms. Other domain of machine learning is the NLP, or natural language processing. Now, these NLP models are the dynamic new deep learning models, and they are very computationally expensive to train. All right, so they require a very good handsome amount of data to train, and they also require some good amount of time for training. So we have the quantum algorithms, the quantum models, like this one. So this is the picture of a recurrent quantum neural network, and it is believed that these quantum models can reduce this training complexity. All right, and the third one is asset pricing. So this asset pricing is nothing but trying to understand the behavior of risk premiums. All right, so stock returns, for example, again it is achieved using machine learning algorithms, deep learning algorithms like LSTMs, and again we have the quantum versions of these called the quantum LSTMs as well. So talking about numerical risk modeling, we have derivative pricing as well as risk analysis. So this derivative is nothing but a contract between parties whose values is just based on some underlying asset, and so this asset can be stochastic, and so this the pricing of derivative then becomes a little more difficult and a complex task. The other is risk analysis, and of course, it just means that calculating risk metrics are really important because they can determine the probability and the amount of loss. So these are the two aspects where quantum is trying to help with respect to the numerical risk modeling. Talking about optimization, we have the credit score. So the financial institutions, banks, for example, give loans to individuals, and to determine which are the key features that should be considered before uh, giving these loans. Okay, so we have credit score for that, and to optimize this problem, there are already various machine learning algorithms and other statistical methods. But again, we have our quantum trying to play a role here because of its key features that we have already discussed previously. Talking about the other aspect, which is the financial crash. So, a financial network can be viewed as collection of entities whose valuations are interconnected. So, you can just try to predict that from these individual entities that this network is about to crash and we are about to have a financial crash. Of course, this is a very difficult problem to solve, but again, it is believed that our friend quantum computer is trying to get into this as well. So now we have the other two aspects in the optimization domain, which are hedging and swap netting. All right. So talking about the first, so this is just hedging is nothing but a way of risk minimization. So minimization again leads to optimization. All right. And talking about the other one, so swap netting, if you talk about this, swap is nothing but a contract where two parties agree to exchange cash flows for some specific term periodically. All right. So, for example, you can just think of the foreign exchange currency swaps. All right. So again, because the time aspect is involved here, so we again this leads us to the optimization domain. All right. So to optimize this aspect. So actually, there are other aspects as well that are affected, but I have chosen these four, and there's a reason to it because the quantum approach that is used to solve all these four problems goes through something called Cubo. So in the second video of the playlist that you can see, I have already solved a Cubo problem. Of course, it was a very simple Cubo problem, but you can still get a sense of how this Cubo problem is solved. And the problem is solved using the Ocean software toolkit by D-Wave Systems. All right. And of course, I will be explaining the theory behind Cubo in the upcoming video of this playlist that will be premiered on the coming Monday at 7 p.m. IST. So make sure that you subscribe to the channel or at least bookmark this playlist. Apart from that, you can utilize this playlist on the channel that uses a GUI app and helps you to understand quantum computing visually. All right. So if you look here, these are the 11 weeks of understanding quantum computing, and these are the topics that are covered. And there are hardly any videos that are that surpasses 10 or even 13 minutes. I think the 13 minutes is the longest. So I think it's a great resource that you can utilize to learn quantum computing, and eventually this channel will try to help you to understand quantum machine learning by help you to understand quantum computing and how it merges with machine learning and how it affects various industries. All right. So I hope you like the video, and I will meet you next time in some other video. But until then, take care.